All right. Okay. Right, guys. Okay, so now I think it's recording, right? Okay, yes, it's recording. All right, so yeah, so in the last, I think chapter 2, so we have seen different ways actually to represent data, right? Like frequency tables, and histograms. So today we're gonna discuss this another way to represent data, the scatter diagram, okay? And we're gonna study actually the relationship or connection between like two different variables. All right, so yeah, so let me just write down what I said. So we have seen different ways, to represent data. Okay, so for example, histograms, frequency tables, etc. Ogives, frequency tables, histograms, ogives, right, etc. So today we're gonna try to, so we're gonna discuss another way to represent data, which is the scatter diagram. Okay, so today, so another way, I'm gonna discuss another way to represent data, and that's the scatter diagram. Okay. All right, guys. Yeah, so I'm gonna define the scatter diagram. I'm gonna show an example how we graph the scatter diagram. All right. So let me start just first with the definition. So what's a scatter diagram? So definition. So scatter diagram is actually, it's a graph. Like, like ogive. Ogive was a graph. So it's a graph. So it's a graph where data points so we're gonna have a pair of variables. So we're gonna have X and Y. So where data, let's say pairs X, Y. So we're gonna have two variables, X and Y are, so we're gonna plot the pairs X, Y. So you're gonna use, of course, X axis and a Y axis and a Y axis, right? Anyway, so the variable X actually has a name. It's called the explanatory variable. So the X variable, so the variable X is actually called explanatory variable. So what do I mean by explanatory variable? I mean, it's a variable which has been, like manipulated by in an experiment, okay, for example. And we're gonna have another variable the variable y, which actually the variable y is called the response variable. Okay, so we're gonna have two variables. So response variable, what I mean by response variable, is actually a variable about which a researcher is asking like a specific question or something, okay? So yeah, so for example, so let's say, for example, x is x, the variable x, it's the magnitude of an earthquake. So x is, let's say, the magnitude of an earthquake. Okay, we're gonna use as units. We can use, for example, the Richter's scale as units. We're gonna use the Richter's scale. Okay, and so that's my variable x. And now the variable y. Let's say the variable y, it's the depth. Below the surface, at which the earthquake occurs. Okay, and let's say as units for the variable y, we're gonna use kilometers. Okay, units here for the variable y. So we're gonna use kilometers. Okay. Anyway, so we have these two variables, x and y. So x is the magnitude of the earthquake, and the y, that's the depth of the earthquake, right? Now, so we're gonna be interested in, we're gonna try to see if there is like a connection or like a relationship between the magnitude of the earthquake and its depth. Okay, so the question here, so what we're gonna try to do is we're gonna study, or we're gonna see if there is a relationship or connection between the x and the y. So the question is the magnitude is the magnitude of let's say the earthquake, okay, so that will be my variable x, right? This is my variable x. So we'll see if there's a connection or a relationship between the magnitude of the earthquake and the depth and its depth, right? So it is the magnitude of an earthquake is related to the depth to its depth, right? To the depth below the surface. At which the earthquake occurs. So the main question here, guys, is that if there is a relationship or a connection between these two variables, the x and the variable y. Okay, so in other words, is there any relationship or connection, or relationship between the x and y, the two variables, right? The x, again, x, that's the magnitude of the earthquake, and the y, the variable y, is going to be its depth, okay? Connection or relationship between X and Y. Between X and Y. Okay, so let's say we have the following data. So we have the following data. As I said, we're gonna have two different variables, X and Y. So we have the following, so we have the following data. Okay, so we're gonna have a table with the values of X. So in the first row, we're gonna have the values of X, and then the second row, we're gonna have the values of Y. Okay, so how many values do we have? Let's say 1, 2, 3, 4, 5, 6, 7. So I have like 7 values. So X, 1, 2, 3, 4, 5, 6, and then 7. All right. So for example, if the magnitude of my earthquake is, let's say 2.9 on, again, a Richter's scale, then Y, the depth of the earthquake is actually, let's say it's 5 kilometers. Okay, so if the magnitude is, let's say 4.2, then the depth is gonna be 10 kilometers. All right, etc. So then I think I have like the third column, I have 3.3, and the depth Y is going to be 11.2. Okay, 4.5, the depth is going to be 10. 2.6, the depth is going to be 7.9. Let's say this is 3.2, and then the depth is going to be 3.9, and finally if the magnitude is 3.4, the Y depth is going to be 5.5. Okay, that's our data. So as I said, first, I'm going to try to graph this scatter diagram. Okay, so the question here. So what we need to do first, so we're gonna graph the corresponding scatter diagram. Okay, so in this scatter diagram, guys, we're gonna have two axes, right? The x-axis and the y-axis. So the horizontal axis is going to be your x-axis. So here is my x-axis. Okay. So as you can see, the values of x, they are like between, well, as you can see, we have like 2.9 right here. And then, so it's the values of x, they are like between 2.9 and 4.5, right? There's 4.2, of course, 3.3, etc. 2.6 here, 3.2, 3.4. And then, so the largest value actually of x in this data is 4.5, right? So your x, so here on the x-axis, let's say here's, for example, let's say this is a 0. Okay, I'm gonna take probably more space, so I'm gonna just put my x-axis right here. This is your x-axis, so you're gonna need 0. Then, for example, here's 2. All right, and then, as I said, so we're gonna need like values like 2.6, right? There's 2.6. So let's say this is 2. Here it's, let's say this is 3, and this one here, it's 4, okay? So this is, let's say 2.5 right here, and this is 3.5, okay? 2.5, of course, it's just the middle of 2 and 3, right? Etc. Anyway, so that's for my x-axis. Now for my y-axis, so y-axis is gonna be a vertical axis. So it's gonna pass through the 0, of course, right here. Okay, and here's my y-axis. Now, what are the possible values of y? So as you can see from the data, so here we have, for example, the smallest value of y would be like 3.9, right? And then we have like, 5, 5.5, etc. We have 7.9, and actually the largest value of y would be 11.2, right? So I'm gonna put on the y-axis, so I'm gonna put, I guess, I'm gonna start with, let's say, 5 somewhere right here. Okay, this is 5. And so let's say this is 6, 7, 8, 9, 10, and then 11, right? So, well, I'm gonna plot the first point. So what's the first point? The first point, as you can see, guys, it's the x is, it's actually 2.9, and the y would be 5, right? So the first point, so as you can see, the first point, the coordinates of the first point are, 2.9, 2.9, and so this is 2.9, and your y is 5. Okay, so again, this is your x, and this is your y. So my x is 2.9. So let's find 2.9 on the x-axis, right? Because that's the value of my x, right? This is the value of my x. It's 2.9. So 2.9 would be somewhere, it's gonna be very close to 3, right? So it's somewhere right here. This would be 2.9, right? Now, what's the corresponding y? The corresponding y is actually 5, right? So if, as you can see here from the table, the corresponding y is 5. So you can draw like a, vertical line starting from 2.9, and then you have to stop at the level or height y equals to 5. So as you can see right here, this is where my y is equal to 5, right? So this point right here, that will be my first point. So as you can see, guys, so the y the corresponding y is 5, and the corresponding x is 2.9, right? That will be my first point. Any question, guys, how I plotted this first point? You see how I got this point? So it corresponds, again, it's the first column, right? It's where x is 2.9, y is 5, right? So you start with x. Your x is 2.9, so it's gonna be somewhere right here, close to 3, right? And then you can draw like a vertical line, and then you have to stop where at the level where y is equal to 5, right? And that will be your first point. Next, for example, next point. Well, as you can see, next point, it's this. The x is gonna be 4.2, and the corresponding y, it's 10, right? So first we start with the 4.2. So where's my 4.2? Well, 4.2, it's, it's kind of close to 4. So let's say this is my 4.2, okay? And so the corresponding y, the corresponding height, it's 10, right? So I'm gonna go with a vertical line starting from 4.2, and we have to stop at the level or height where y is equal to 10, right? So right here. So I'm gonna stop right here, and that will be my second point, right? And as you can see, so the corresponding, so x is 4.2, and the corresponding y, it's 10. That will be my second point. Okay, so again, the idea here is just to plot, all these data pairs, all these points. So for example, next point would be like 3.3 and 11.2. So that would be somewhere like 3.3 and 11.2. So it's gonna be, for example, it's gonna be this point, I guess. Okay. Next, we have 4.5 and then 10. So 4.5 and then 10. So it's gonna be probably somewhere right here. Okay. Next point, it's 2.6 and 7.9. So 2.6 and 7.9. So it's gonna be somewhere, probably somewhere right here. Next point, it's 3.2 and 3.9. So probably, oh yeah, 3.9. So 3, of course, gonna be somewhere right here. Okay, so yeah, 3.2, 3.9. So it's gonna be probably so somewhere right here. Okay, and the last point, that's 3.4, 5.5. So probably somewhere right here. Okay. So that will be your scatter diagram. Okay, it's just a bunch of points, as you can see. So you don't have to, you don't have to connect these points. So this is actually your scatter diagram. Let me just erase this thing here. Okay, so this is what I call the scatter diagram. Okay. So all I did, guys, was I just plotted all the points in this this graph using, of course, two axes, the x-axis and the y-axis. Okay. And is there any question, guys? So far, so good. Okay. Now, so we have all these points. Yes.
It's perfect, thank you.
Okay, no questions. Okay, perfect. All right. Now, guys, as I said, so we have all these points, right? And the idea is what we want to do is we're gonna try to find if there is any relation between, the variable x and the variable y. Okay. So now the question is the following. Is there a relationship or a connection or a correlation So what I mean by correlation is a connection or a relationship between the variable x and the variable y. Okay. Well, I would say, so the simplest correlation we can have or relation we can have, it's actually called a linear correlation. Okay, so a possible correlation is a linear correlation. Okay, so so what do I mean by linear correlation? Well, linear correlation means just it's a straight line relationship between the two variables. Okay, so so linear correlation is just a straight line, straight line relationship between the two variables. X and Y. Okay, and actually when we have a straight line, relationship, it means that the two variables actually they change at a constant rate. Okay, so that's what I mean. That's what we mean by a linear correlation. So in other words, the two variables, they change at a constant rate. At a constant rate. Okay, so the data in your scatter diagram, the data is going to resemble a line. Okay, so in the scatter diagram, in the data in the scatter diagram. So in the scatter diagram, we'll have like the data will resemble a line. Okay, in the scatter diagram, the data will resemble a line. Okay, so in other words, this scatter diagram is gonna look like, so here is your scatter diagram. You know, so you have this bunch of points. Okay, and of course, the best line here, guys, is the line that comes closest to each point. So like in this case, probably the best line would be, for example, let's say this line right here. Okay, so in this case, so we have sort of a linear correlation. So we have, my line is not really straight, so probably I should, let me draw again this line. So again, I have all these points. All right, and then, so here we're gonna have, let's say this line, which is kind of, is the closest to each point, kind of, okay? So this is what I call a linear correlation, okay? And again, guys, so the best line would be the line, so the best line is the line that comes closest to each point, okay? That would be your best line. So the best line is the line that comes closest to each point. Okay, so to each point. So like in this case, we have, as I said, so if you draw this blue straight line, okay, it's kind of very close to each point, right? And so that's what I call a linear correlation, right? So it's this is a linear relationship or linear connection between your variable X and your variable Y, okay? In the case, if you, let's say your scatter diagram look like, so if you don't have a linear correlation, then your scatter diagram would be like, for example, so here, let's say you have like a, you know, like a lot of points, and as you can see here, I mean, there is no you know, line which is really, so the best line here, which is closest to each point, it actually do not exist, right? So it's the points are kind of you know, spread. So there's no straight line which is kind of very close to each point, right? So in this case, we don't really have a linear correlation, right? So this is, so here there's no linear correlation. Okay. Another example. So here, for example, let's say you have these points right here. So again, the idea is that your data do not resemble a line, right? So like here, here you don't have a line. Like your data is going to resemble like it's not a line. You're going to have like something like this right here, and that's not a straight line, right? So yeah, so here there is no linear correlation, right? So again, so when I say no linear correlation, guys, it means that the data do not resemble a line. No linear correlation. So means that the data do not resemble a line, a straight line. Okay. Well, of course, if like here, as you can see, guys, like in this example right here, I mean, not all the points lie on this blue line, right? But if for some reason all the points they lie on a straight line, then actually we have what we call a perfect linear correlation. Okay, so if all the points lie on the same straight line, then we're going to have a perfect linear correlation. Okay, so so for example, well, we can take it as definition. Okay. So if all the points lie on a straight line, okay, then X and Y, they have a perfect linear correlation. Okay, then X and Y, they have a perfect, what we call a perfect linear correlation. Okay, so for example, so let's say your scatter diagram looks like the following. So let's say you have like your data points. They're gonna be all the points. They're gonna lie on the same line. Okay, so this is your scatter diagram. Okay, and as you can see, there is a line which passes through all the points at the same time, right? So this, let's say this blue line right here, okay, passes through all the points, right? So in this case, again, this is your scatter diagram. This is your scatter diagram. So in this case, we say that, so X and Y have perfect linear correlation. So this is a perfect linear correlation. Okay. All right. Now, of course, we can distinguish actually between two cases for this, the linear correlation. So, you can have like, so if you have a line which goes down, for example, right here. Let's say this is your scatter diagram again, okay? And then you have a line, for example, which goes down, right? Like this line here, okay? Again, this line, it's actually the closest, let's say this is the best line that comes closest to each point, okay? So in this case, this line, it's going down, right? And so in other words, so the line here is going down. So in other words, it is going down. So in other words, as X increases, the values of Y, they're gonna decrease, okay? So as the values of X increase, right? As the values of X, so the values of Y, they decrease, right? So the values, let me write down this, the values of Y decrease, right? As the values of X increase. Values of X increase. Okay, so the values, again, the idea here is that the values of Y are decreasing, right? Because your line is just going down, okay? And now, if you have a line which is going up, so yeah, actually in this case, we say that the X and Y, so in this case, we say that X and Y have actually a negative correlation, right? Because the rate, you know, as I said, when you have a linear correlation, it means that the two variables, they change at a constant rate. So in this case, the rate is negative. So here we say that X and Y, so X and Y have a negative correlation. Okay, if your line is going down. Now, of course, we have a positive correlation. So when your line is going up, so let's say you have the following scatter diagram. And so let's say your points, your data pairs are the following. So for example, you have these points. Okay, and the best line in this case, which is the closest to each point, let's say would be this one right here, for example, okay? So yeah, so in this case, X and Y, they're gonna have a positive correlation, right? So the values of Y increase, right, as the values of X increase, right? So the values of Y increase as the values of X increase, okay? Okay, so the values of Y, they are increasing. So in this case, as I said, X and Y, they're gonna have a positive. X and Y have a positive. They have a positive correlation. Okay. So yeah. So as you can see, guys, so yeah, so we have different kind of linear correlations, right? So we have there is this perfect linear correlation when all the points they lie on the same line. We have negative correlation when your line is going down, and then you have this positive correlation when your line is going up, right? Now, let's come back to our example, right? So our example with the magnitude of the earthquake. So let's just come back to the example. Back to the example. Okay. So yeah, as I said, what we want to do here in this example, we want to try to see if there is a correlation or relationship between the variable x and y, right? And this is our scatter diagram, right? And so we're gonna try to see if there is like a negative or positive correlation, and if the correlation between x and y is strong or like low connection between x and y, or let's say a moderate connection between x and y. Okay, so what we're gonna do next, we're gonna try to compute. So there's a measurement that we can compute to describe the strength of this linear correlation between the two variables. Okay, so there is a measurement. So now the idea is, so we're gonna compute a coefficient. It's actually called the sample correlation coefficient, and this coefficient is gonna describe the strength of the correlation, the linear correlation between the two variables. Okay, so we're gonna compute. So the idea is to compute now a coefficient that describes the strength of the linear correlation between, or linear relationship between the two variables, that describes the strength of so the linear relationship or correlation between the two variables x and y. Between x and y, the two variables x and y. Okay, so this coefficient, as I said, is called the sample correlation coefficient. So the sample correlation coefficient. Okay. And yeah, I'm gonna show you my example how to compute this sample correlation coefficient. And as I said, it's gonna help us to describe this relationship between the variables x and y. Okay. Yeah, so first I'm gonna show you the steps. So first I'm gonna denote this sample correlation coefficient by R. So we denote by R this the sample correlation coefficient. Okay. And so I'm going to explain the steps, how to compute this. I'm going to explain the formula of how to compute this R. So as a first step, I guess, so you have to compute. So step one, so you have to compute the sum of the x's. So step one. So we need to compute. So we compute the sum of the x's, okay? So like in our example, I'm gonna probably, I can probably write down the example again right here. Let me just write down here. So as I said, I'm gonna get back to the example. Okay. So again, you have x, y, x again, that's the magnitude of the earthquake, and y, its depth, right? So we have all these values. So we said x is, so first x was 2.9, you know, we have 4.2, we have the 3.3, 4.5, we had the 2.6, right? We had the 3.2, we have the 3.4. Okay, for y, we have 5, 10, I think 11.2, then 10, we have 7.9, we have 3.9 and 5.5, right? Yeah, so first step, we're gonna compute the sum of the x's. So step one, so we need to find the sum of the x's. Okay, so like in this example, that will be, you know, just like the 2.9 plus, you know, 4.2 plus 3.3 plus the 4.5, you know, plus 2.6 plus the 3.2, and then plus the 3.4. Okay, I'm probably gonna put the 3.4 next to the 3.2. Yeah, plus 3.4. Okay, so like in this example, I mean, so if you use a calculator, of course, you need to use a calculator. So then the sum of the x's here would be, I think, 24.1. Okay, so that's the sum of the x's. Okay, then you're gonna need the sum of the y's. So we're gonna need the sum of the y's. So that would be like in this example, that would be 5, you know, plus 10, plus 11.2, plus 10, plus 7.9, plus 3.9, plus 5.5. So the sum of the y's. So in this case, so if you use your calculator, I think the sum of the y's is gonna be, let's see, I think it's 53.5. All right. So that will be the sum of the y's. Right, and then we're gonna need the sum of the x squared. Okay, so the sum of the x squared, the data, the value of x squared. So it's like, you know, it's like 2.9 squared, right? That's 2.9 times 2.9 plus next value, that's the 4.2 square, 4.2 times 4.2, etc. Right? So this is 3.3 square, you know, 4.5 square, plus 2.6 square, plus 3.2 square, right? And then 3.4 square. Okay. And of course, then you do like 2.9, you know, 2.9 times 2.9, etc. For example, 2.9 times 2.9, that will be equal to 8 point. So this is like 8.41. right? This is, again, this is just 2.9 times 2.9, okay? So this is just 2.9 times 2.9, okay? Plus, you know, you do the 4.2 times 4.2. So that will be actually 4.2 times 4.2. That will be equal to 17, I think, 0.64, etc. So this is 4.2 times 4.2, okay, plus, you know, etc. right here. And I think the sum is gonna be the sum of this thing here, the sum of x squares. So this sum is gonna be 85.75. All right. Do the same thing for y. So we're gonna need the sum of the y square. Okay, so well, as you can see, it's a lot of computations here, but then we're gonna be able to compute this you know, this r, this the sample correlation coefficient, and then we can use the r to describe the relationship or the correlation between x and y. Okay, so let me just so write down here for the sum of the y square. As I said, we need the sum of the y square, sum of the y square. So there'll be like, you know, 5 square plus like 10 square plus 11.2 square, you know, 7.9 square plus the 3.9 square plus the 5.5 square, right? I mean, that would be like, you know, 5 square would be like 25, 5 times 5 is 25, 10 times 10, it's 100, you know, etc. Okay, and the total, the sum of the y squares, I think it's, if I'm not mistaken, it's actually 458.31. Okay, and then finally, the last thing you need to compute, guys, is the sum of x times y. So we're gonna need the sum of x times y. Okay, so like, so in this example, so first x is 2.9, corresponding y is 5. So that will be like 2.9 times 5. You know, so first you have like 2.9 times 5 times 5, right? Plus next, so next would be like the next value of x is 4.2 times 10, you know. So plus here it's 4.2 times 10 times 10, etc. Right? So it's then like 3.3 times 11.2, you know, plus the 4.5 times 10, etc. 2.6 times 7.9, the 3.2 times the 3.9, and plus 3.4 times 5.5. Okay. So then the sum here, if I'm not mistaken, this sum would be, so this sum of x times y is going to be equal to, so the total is going to be actually 190.18. Okay, that's the sum of x times y. All right, guys. So we got the sum of x, sum of y, sum of x squared, sum of y squared, sum of x, sum of the x times y. Now we can compute the sample, our sample correlation coefficient. So then in the step number 2, once you are done with this, guys, then we can compute step number 2. So here's the formula for R, the sample correlation coefficient, formula of the sample correlation coefficient. So R is going to be equal to, all right, so that'll be equal to, so first in the top, so it's a fraction. In the top, we're going to have N. Okay, so N, that's the size of the sample, right? So that's the number of data values. If you have, for example, so how many, for example, here we have like how many data pairs? So we have like 1, 2, 3, 4, 5, 6, 7, right? So it's N times the sum. So N times the sum of X, Y, okay? Times, so this is times N times the sum of X, Y minus, and then you have this sum of X, sum of the X's times the sum of the Y's, okay, over, so this whole thing divided by, all right? Just be careful here. So this is actually, we're gonna have two square roots. So first square root here, this is the square root of, so we have N times the sum of X squared minus the square of the sum of X's, okay? And again, everything here is under the square root. Times, and then we have another square root with the Y's. So here we're gonna have N sum of the Y square minus sum of the Y's square. Okay. So like, all right, so like in our example, as I said, N, so that's the number of the data pairs. So here we have like 7 data pairs, right? So we have 1, 2, 3, 4, 5, 6, 7, right? So we have like 7 points. So N is 7 in our example. So in our example, N is 7, right? So then R, so then R would be equal to, so then R is going to be equal to, so N, as I said, it's 7 times the sum of XY. XY, sum of the XYs, we said it's 1. So this is times here. The sum of X times Y, that's, we said it's 190.18. Okay. And then minus sum of the X's, I think we said it's a 24.1. So this is 24.1 times the sum of the Y's. I think the sum of the Y's, I think was 53.5. Right, over. And then we have 2 square roots. Okay, so we have this square root of first. So we have N, again, N is 7 times the sum of the X squared. We said this sum of X squared is actually 85.75, I think, right? The sum of the X squared, as you can see, yes, it's 85.75. So 85.75. I'm gonna need some space here, so let me write it. So 85, yes, times 85.75 minus, as you can see here, there's this minus, and then the square of the sum of the x's, right? The sum of the x's, it's 24.1, so it's minus. So the 24.1, the sum of the x's square. Now we do the same thing with the y's. So this whole thing here times, now for the y's, so it's again 7 times the sum of the y square. Sum of the y square, it's 458.31, right? Minus, and then the square of the sum of the y's. Sum of the y's is 53.5, right? So it's 53.5 square. So there's a square right here. Okay, there's a square right here. Okay. All right, guys. So as you can see, the formula of this R, kind of, I mean, it takes time actually to compute this R. So of course, now you need to do the first, you start with the top, right? So it's like, so here, first you do the, you know, in this R, first you do the, first you have like this 7 times, you know, 190.18, right? That's, so that's a 7 times 190.18. So that'll be equal to, I think that will be like 1331.26, right? Minus, and then you do the, you know, the 24, this thing right here. So I did the 7 times 190.18. That's the 1331, etc. Now we need to do this thing here, the 24, you know, 24.1 times the 53.5. So that's actually 1200. So this is actually 1200. Oh, sorry, I'm gonna use the same color. So 1289.35. Okay, that's this blue thing right here. Okay, now the denominator, you need to be careful with the denominator. So, so in this denominator, first we have this square root. First, you start with this 7 times, as you can see. So first we start with this 7 times the 85.75. Okay, so we start with this 7 times 85.75. Okay, so that will be, for example, that would be, I think, 600. Oops. So this would be 600.25 minus, all right. So let me just circle this thing here, all right. And then there's this 24.1 square, right? There's this 24.1 square, okay? So 24.1 square actually is gonna be 500, oops. So it's gonna be 580 minus 0.81, right? Now, times another square root, so it's the same thing here. So you have this 7, you know, times the 458.31. So that will be equal to, if you use your calculator, of course, that will be equal to 3,208.17 minus, so what I did here is this thing right here, okay, minus the 53.5 square, right, 53.5 square, so that will be equal to, so let me use here same color, this thing right here, so that will be equal to 2,000, I think, 862.25. okay? Okay, so let's finish the top. So we are almost done. So the top, we're gonna have, so R again. So that's 1331.26, right? Minus the 1289.35. So that'll be equal to, so the top would be at like 41.91, okay? In the bottom, guys, so denominator, just be careful. So first we have to subtract. So we have these two square roots, right? So there's a square root here, and there's another square root right here. So first we have this 600, 0.25 minus the 580.81, right? So that will be equal, of course, to 19.44. Okay. And on the other hand, you have this 3,208.17, minus the 2,862.25. So that'll be equal actually to, so this is actually 345.92. And then guys, you have to take the square root of the 19.44 and the square root of the 19.44. So for example, square root of 19.44, that would be, so here, so R, so that we are done with the top, right? So here, so this square root right here is going to be square root of 19.44. So that'll be, I think, 4.4 or something, 4.4 times. This is multiplication right here, right? And then you have like square root of 345.92, which is, if you use your calculator, of course, you need to use your calculator, that will be like 18.59. Okay, 59. Anyway, so this is 41.91 over, so the bottom would be the 4.4 times the 18, etc. That would be 81.83 or something, or 84, I think, 84. So when you divide, so finally your R is going to be equal to, so this R, so this R, your the sample correlation coefficient, so it's going to be equal to so approximately 0.511 or 0.51, let's say. Okay, so it's approximately 0.51. Okay, so next, how do we use this number to describe? So next question is, so we're gonna use, as I said, we're gonna use this number. So next question is, how do we use this number to describe? So how do we use R to describe the relationship between, or the correlation between X and Y? To describe the correlation between, the linear correlation between X and Y. Well, so there are a couple of things you need to know about R, guys. So first, your R is actually always between -1 and +1. Okay, so, oops. So things to know about R. So this R, this number R is actually always, so so things to know about R. All right, so first R is always between -1 and +1. Okay, so R is always between -1 and +1. Okay, so if R is actually is exactly equal to 1, so if R if R is exactly equal to 1, then we have a perfect linear correlation. Okay, so then you have a perfect linear correlation. Okay. And if R the same, so if R is -1, it's also a perfect linear correlation. Okay. Now, if R is positive, well, before that, let's say if R is close to 1 or -1, okay? So if R is close to 1 or -1, so then, you know, the relationship between X and Y is close to linear. It's not exactly linear. It's not a perfect linear correlation. It's close to linear, okay? So the relationship between X and Y, relationship between X and Y are close to linear. Close to linear. Which means that your scatter diagram, the data actually, the data resembles a line. It's not a straight line, but it resembles a line, okay? It's close to a linear. Now, if R is close to 0, if R close to 0, then there is no, very little or no correlation between X and Y, okay? If R close to 0, there is little or no correlation or relationship between X and Y. Between X and Y, okay? So if R, like in our example, guys, our R, it's not, it's 0.51, right? It's not really close to 1. It's not really close to 0. It's like between, in the middle between 0 and 1, right? So in this case, we have like sort of moderate correlation between X and Y. It's not really a strong correlation. It's not a low correlation. It's, between. And so it's moderate correlation, okay? So if, sorry about that. So if your R is, let's say, is in the middle, like a bit close to 0.5 or negative 0.5. So if R close to 0.5 or negative 0.5, then you have like a moderate correlation between X and Y. Between X and Y. Okay. Now, the sign of Y. So if R is, sign of R. So if R is positive, then we have a positive correlation. So as X increase, Y increases, okay? So if R is positive, so if R is positive, then we have actually a positive correlation. So as, so the Y increases as X increases. So in other words, so the line would be, is actually going up, right? So we have a positive positive correlation if R is positive. And so if R is negative, of course, the Y is going to decrease as X increase, right? So we have we're going to have like a line which goes down, right? So if R is negative, the Y is going to decrease as X increases. So we have a negative correlation. Okay. One more thing, guys, is that this correlation coefficient is actually independent of units. Okay, it doesn't depend on the units. So let me just write it down here. Last thing to know about R. So R is independent of units. Is independent of units. Okay. So yeah, so I mean, so again, the idea is the following. So if you so when you say R is close to 0 or R is equal to 0, again, it means that there is no linear correlation, right? And so your scatter diagram, you know, it's gonna be like something like this here. So the points are dispersed, okay? If R is, you know, close to 1 or -1, so R, let's say close to 1 or close to 1, right? Or -1. So your data or your scatter diagram is gonna look like, you know, the best line here would be, let's say, so your data here is gonna resemble a line, okay, which is going up in this case if your R is close to +1. If R is close to -1, of course, you're gonna have a line which kind of going down. So your scatter diagram is gonna look like something like this right here. Okay, so you're gonna have a negative, of course, negative correlation, right? Etc. So that's the idea. Now, in our case, in our example, R was 0.51, right? So in our example, R is 0.51, okay? So what we can say here is that we have a positive, R is positive, right? So we have a positive correlation, right? So we have a positive, because R is positive, so we have a positive correlation, which means that the values of Y increase as X increases, right? So we have a positive correlation because R is positive, because R is positive. Okay, so in other words, as I said, Y increase as X increase. Y increases as X increases. So in other words, what's Y? Y was the depth of the earthquake, right? So in other words, the depth is going to increase as, so the depth is going to increase as the magnitude of the earthquake increase, right? So because X, the variable X was the magnitude of the earthquake, right? So the depth, which is the Y, the variable Y, increase as the magnitude of the earthquake increase. Okay. So yeah, we have a positive correlation. That's the first thing we can deduce from this R, right? Now, what's the strength of the linear correlation between X and Y? Is it do we have like a strong linear correlation, or moderate linear correlation, or low linear correlation, right? So in this case, because when you are close to zero, you have a very low linear correlation, right? If you are close to one, or close to -1, you have a strong linear correlation. But in this case, it's 0.51, right? Again, it's between 0 and 1, or 0 -1. So the strength of the linear correlation here is actually moderate. Okay, so another thing we can deduce is that R is 0.51, which is in the middle between 0 and 1. So in this case, the linear correlation here, it's not really strong. It's not really a straight line, but it's actually is moderate. Okay. Any question, guys? So as you can see, I mean, this. So that's how we compute this correlation coefficient. And again, so and then you can deduce. So there are some. So this R has, as I said, you can use this R to describe the strength of the linear correlation between the X and Y, and so yeah, so just be careful with the formula. As I said, there are a lot of steps in the formula, and yeah, well, I guess we can probably do an exercise. First, is there any question, guys? Okay, probably not. Okay, so let's do an exercise. So here's an exercise. Exercise. So in this exercise, we have, so again, we have two variables. We have 10 days sample. The X is going to be the number of the police officers on duty. Number of police officers on duty. Okay, and the Y, let's say it's going to be the number of muggings that day. Okay, so we have a 10 days sample. Okay, we have 10 days sample. So of course the question is there a relation between the number of police officers on duty and the number of muggings that day, right? So let's say we have the following data. So we have 10 days sample. So this is X, Y, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for the first day, let's say we have 10 police officers on duty, and then we had 5 muggings that day. Then the next day we have 15 officers on duty. then just two muggings that day, 16. And then here, just one mugging. Here, one day, one officer, and then 9 muggings. Next day, we have 4 officers, 7 muggings that day, 6 here, 8. Let's see here. Let's say 18. This is 1. This is 12. This is 5 here. 14, 3. And then 7. Then here, let's say it's 6. Okay. First question is, so question 1, we need to make or graph the scatter diagram. Okay. Okay, so from B, in B, well, just from the scatter diagram, do you suspect R to be positive or negative? Just from the scatter diagram. Okay. C, we need to compute and see the sample correlation coefficient. So I'm gonna give you the sum of the X's, some of the Y's, guys, because otherwise it's gonna be a lot of computations. So I'm gonna just give you you can check, of course, the values that I'm gonna give you. So compute, compute R. The sample correlation coefficient. Okay. So I'm gonna give you the sum of the X's, etc. Because otherwise, as I said, it's gonna be a lot of, it's gonna take a lot of time. So we can check if, sum of the X's gonna be 103. Some of the Y's, you can check, it's gonna be actually 47. The sum of the X square is gonna be, 13, I think, 147. Sum of the Y square is gonna be 295. And then the sum of X times Y is gonna be 343, okay? Again, just because otherwise it's gonna take a lot of time to compute all these things. And then, so you need to use this, of course, to compute R. Then once you have R, so D, would you say the correlation is, the linear correlation is low or moderate or strong? Okay. And is it positive or negative correlation, right? Is it positive? So D, yeah. So is it positive or negative correlation? And finally in E, so we're gonna use all these informations to deduce if there is any correlation between the number. So do you think, so is there a relationship between the number of the officers, police officers on duty, and the number, is there a relationship between the number of police officers on duty and the number of muggings? Okay. All right, guys. Well, I guess I'm going to give you some time to think about this exercise. So for the scatter diagram, all you have to do is just to plot the data pairs, right? The points, and then and then you have to compute this coefficient R. Okay. So gonna give you some time to think about this. So guys, make sure that you know how to compute this R. I mean, the answer for R, I think R is gonna be like negative, I think it's gonna be negative 0.97 or 96 or 97. Actually, I think it's 97, yeah. Yeah, so it's gonna be close to negative 0.97. Yeah, you need to make sure that you know how to compute this R, okay? So you need to take your time with the formula. When you apply the formula, take your time. Did anyone get the negative 0.97? Okay. You know what, guys? So I'm gonna go over this exercise, and then we have one more exercise. Okay, similar to this one. So I'm gonna try to, explain again how to solve this, and then you can probably try to follow the steps and solve the next exercise. Okay. So, for example, let's start with A. Graph the scatter diagram. Okay, so so when you graph the scatter diagram, of course, you need two axes, the x-axis and the y-axis. Now, for the x-axis, you're gonna need values like, so the smallest value, x value, or the smallest value of x is, as you can see, the smallest value of x is 1, right? And the largest value of x is like 18, right? So when you draw your x-axis, you're gonna need you're gonna need numbers from 1 to let's say 18, right? So when your x-axis, x-axis, so for number 1 or A, right? So you have your scatter diagram. So this is your x-axis. okay? And as I said, the smallest value of x is, of course, you need the 0 first. Yes, the smallest value of x, we said it's 1, so we're gonna need 1, all right? And then the largest value is 18. So let's say 1, this is 2, 3, 4, 5, let's say 6, all right? And then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then 18. Okay, so this is 8 here, etc. This is 10, 11, 12, 13, 14, 15. This is 15 right here. Okay, that's your x-axis. So again, because the smallest value of x is 1, the largest value of x is 18. That's why I needed all these numbers, right, from 1 to 18. Now, for the y-axis, so the values of y, the smallest value of y is, as you can see, the smallest value of y is 1, right? Right here, that's the 1 is the smallest value of y. What will be the largest value of y? Well, it's 9, right? So the values of y that are between like 1 and 9, right? So we're gonna need, so here on the y-axis, we're gonna put, so let's say 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8, and then we said the largest value of y would be 9, right? Okay, so let's plot the first point. So what's the first point? The first point is, so x, as you can see, so your x is 10, your y is, the corresponding y is 5. X is 10, if x is 10, then y is 5, right? So if x is 10, y is 5. So your x is 10 is right here. This is where x is 10, right? Now, corresponding y is 5. So we need to go with the vertical line and we stop at level y equals to 5. So here is where y is equal to 5, right? So we're gonna stop right here. And this would be my first point. Okay, so this is, this corresponds to the first point where x is 10, y is 5. Right? Next point, x is 15. The corresponding y is 2. So when x is 15, y is 2. When x is 15, y is 2. So let's go to x equal to 15. So here x is 15, right? And then we're gonna go with the vertical line and then we're gonna stop at 2, level y is equal to 2. So as you can see here, this is where y is 2. So we're gonna stop right here. So that'll be my second point. So that's the point where x is 15, y is 2. Right, this is, again, this is the y-axis. Any question, guys, how I got these 2 points? The first point, it's x is 10, y is 5. Second point, it's x is 15, y is 2, right? Okay, next point, it's actually x is 16 and y is 1, right? So here is x is 16, this is x 16, y is 1, so they'll be right here. So there'll be this point right here. This is where x is 15, y is 1. Next point, x is 1, y, x is 1, y is 9, right? That will be my next point. X is 1, y, the corresponding y is 9. So if x is 1, so this is x is 1, corresponding y is 9. So we're gonna go up to 9, right? So this is 9 right here. So that'll be this point right here. Okay, next point we have 4, 7. So if X is 4, this is X is 4, we're gonna go up to 7. So here is 7, right? So that'll be this point. Next point, 6, 8. My X is 6. I'm gonna go up to 8. So that'll be this point right here. Next, it's 18, 1. So here's 18, this is 18, and we're gonna go up to level 1. So right here. Next, we have 12, 5. So if my X is 12, so here's 12. I'm gonna go up to 5. So that'll be up to 5, so right here, okay. 14, 3. So X is 14 is right here, and 3 would be right, level Y equals to 3, so that'll be this point right here. And then finally 7, 6. So if X is 7, so here X is 7, we're gonna go up to the level 6. So up to 6, this is where Y is 6. So we're gonna stop right here, and that will be my point. Okay. Any question, guys, about this? So yeah, so this is gonna be my scatter diagram. So I guess I'm gonna just erase these lines. So these lines, again, just to explain you how I got all these points, right? So so I'm just gonna erase these lines right here. Okay. So that will be that's my scatter diagram. Okay, this is my scatter diagram. Okay. Now, guys, I mean, if you try to draw the line, which is kind of that comes closest to each point. Okay, I'm gonna draw the line which comes closest to each point. Then it would be this, for example, I don't know, let's say this line right here, for example, kind of, right? So this is the kind of the best line which comes closest to each point, right? So the best line, which is coming closest to each point. Okay, so as you can see, guys, my data kind of resembles a line, right? My data kind of resembles a line. If you connect these points, as you can see, it's a kind of a straight line. It's not a perfect straight line. It's not a straight line, not exactly straight line, but the kind of resembles a straight line, right? So next question is, do we suspect R to be, do you suspect R to be positive or negative, right? That's the B, right? So in B, do you suspect R to be positive or negative from the scatter diagram? What do you think, guys? Do you think R, the correlation coefficient, is going to be positive or negative? Any guess? So remember, guys, negative, yes, because the line goes down, right? Remember, we said if the R is actually, yes. So if you have a line which goes down, then your R is going to be negative. Yeah, that's very good. Thank you. So because the data resembles a line which goes down. Goes down, right? So then your R, then R is going to be negative. Then R is actually negative. Going to be negative. We expect R to be negative. So we expect R to be negative. Okay, that's very good. So yeah, next. So we're gonna have a negative correlation, right? Now we need to compute R. Okay, so then to compute R, so I'm gonna remind you again the formula for R. This is a coefficient correlation coefficient. So R is supposed to be equal to N, right? And then you have the sum of XY minus, and then we have the sum of the x's times the sum of the y's. So this is the top, and in the bottom, so just be careful. Again, you have two square roots. So this is N times the sum of the x square minus the square of the sum of the x's. And then there's another square root with same thing with the y. So we have like sum of the y square minus square of the sum of the y's, okay? First, what will be N? So again, N is just the number of the points or the number of the data pairs or the data of the points. So here we have like, so how many x's or how many y's? We have like 10, right? It's a 10 days sample, right? So we have 1, 2, 3, 4, 5, 6, etc., 7, 8, 9, 10. Okay, so we have 10 points. So N is 10. We have a 10 days sample, so N is 10. Okay, N is 10. As I said, the sum of X times Y, well, you can check this is sum, but it's gonna be 343. Okay, I said the sum of the X's is gonna be 103. Okay, if you compute the sum of the X's, if you compute the sum of the Y's, it's gonna be 47. If you compute the sum of the X squared, so X squared plus, you know, the square of the X's, so that will be 1347. And the sum of the Y squared, that will be 295. Okay, so I need to plug all these numbers now in the formula, right? So my R, in the top I have N, right? This is N right here. That will be 10 times the sum of the XY, X times Y, the sum of the XY, that's the 343, right? So times 343 minus, and then we have the sum of the X's, that's the 103, times the sum of the Y's, we said it's 47, over. Here, I'm gonna have two square roots. So again, N, as you can see right here, there's an N, so which is 10, of course, times the sum of the X squared. So that's 1347. So times 1347 minus the square of the sum of the X's. Sum of the X's, it's the 103. So that's like 103 square times, again, another square root, same thing with the Y's. So N, which is of course 10. Let's just erase this thing here. So it's 10 times the sum of the Y square. It's this thing here, 295 minus, and then the square of the sum of the Y's. So the sum of the Y's, it's this 47. So it's like 47, and then there's a square. Okay. All right, so let's compute this thing. As I said, well, then the answer should be like negative, 0.97 or 96. So let's do it. First, So here in the top, we can start with this, 10 times the 343, use your calculator again. So that will be 3,430, of course, minus, right? And then we have this 103 times 47, right? So 103 times 47, that will be actually equal to 4,000. So this is actually 4,841. Okay. So I think the top, it's not a problem. I think you need to be careful with the denominator, guys. So here in the denominator, we have like this square root. First, we have 10 times. So as you can see, we have this 10 times the 1,347, right? So that will be 13. So that will be times 10. So that will be 13,470. Now 103 square, that's like 103 times 103. So that will be equal to so that's equal to 10,609. Okay, so the 10,609, that's this 100 and 103 square, right? That's 103 times 103. All right, now the second square root. We have first 10 times 295. This 10 here times 295. So that will be 2,950, right? Minus the 47 square. So that will be equal to 2,209. Okay, so this thing here, 47 square, that will be the 2,209. All right. Now, what we need to do next, guys. So first, the top, you can subtract. So the 3,000, that's 3,430, etc. Minus, so that'll be minus or negative. So it's minus the 4,841, right? So that'll be equal to actually negative. So the top, this is negative 1,411, I think. All right. So that's the difference between the two numbers in the top. Now, in the bottom, guys. So first, we need to do what's inside under the square root. So the first square root, we have like under the first square root, we have this 13,470, minus the 10,609. So that'll be equal to, actually, if I'm not mistaken, this is 2,800. 2,861. Okay. So that's my first square root times my second square root. So this is times my second square root. It's this 2,950 minus 2,209. So that will be 700 and 741. Okay. Now we need to do what's the square roots, right? So then R. So R is going to be negative this 1,411 over. So first we need to do the square root of 2,861, right? So that will be equal to, I think, 53.48 or something. Okay. So again, this is this square root here of 2,861 should be this 53.48. Okay. Times the square root of 749. So that will be equal to 27. So this is 27. Oops. So this is 27.22, I think, right? So this thing, this is just 27.22, okay? Now we multiply, we are almost done. So your R is gonna be negative this 1411 over, and then you multiply these two numbers, the 27.22, etc., by the 53 point, the 48, and that will be equal to, I think, 1455.7 or 0.8, okay? And then when you divide, this is 0.8, of course. So when you divide, that's negative 1411 over the 1455.8. So as I said, this is approximately, it's negative 0.97 or 969, let's say 97, okay? So yeah, so as we expected, R, as you can see, R is negative, right? Now, next question is, would you say the linear correlation is low, moderate, or strong? And is it positive or negative correlation, right? So because R is negative, so R is negative, right? So R is negative, as we said, we have a negative correlation. Okay. Now, is this linear correlation strong, moderate, or low? Well, it's so negative 0.97. It's very close to negative 1, right? So negative 0.97 is very close to negative 1, right? This is very close to negative 1. It's almost negative 1. Very close to negative 1. Okay. Remember, guys, if you have like R equals to negative 1, it means we have a perfect linear correlation, right? So all the points, they're gonna lie on the same straight line. Okay, so this is very close to negative 1, so it's very strong. So we have a very strong correlation. That's very strong. It's a very strong linear correlation. Okay, because it's close to negative 1. Then we're almost done. And then, yeah. So is there a relationship between the number of officers, police officers on duty, and the number of muggings, guys? Well, the thing is, we have this very strong negative, it's a very strong negative correlation, right? So if it's negative, it means that the values of Y, they're gonna decrease as the values of X increase. So what's Y? Y is supposed to be the number of muggings, right? Oops, what happened? Oops, sorry. Yeah, oops, okay. So, yes, right here. Yeah, so R is negative, right? Because R is negative as, so the Y, so Y decreases as X increase, right? Because we have a line which goes down. So Y, again, that's the number of, Y is the number of muggings, right? That's the number of muggings. And the X, that's the number of the police officers, right? The officers on duty, right? So what we are saying is that Y decreases. So Y, that's the number of muggings. So the number of muggings actually decreases as X increase. X is the number of officers, right? So as the number of officers, police officers increase. Increases. Okay, so that's the conclusion here. All right, guys. Okay, so I guess we don't have time to do one more example. or one more exercise. Probably I'm gonna do it. I'm gonna do one more example or exercise next time, because I need to make sure that you know how to compute this R and how to deduce, the strength, or how to describe the strength of the correlation between X and Y using R. Anyway, so I'm gonna stop here, guys. Thank you for listening, and I will see you in person on Wednesday. All right. Thank you, everyone, and see you on Wednesday. Good night.
Okay, thank you. Good night, Professor.
Good night. Thank you.
Good night.